Hello everyone, in this example we're going to learn how to use complex numbers and how to use operations involving complex numbers. So suppose I have something like, well, first let me introduce you to a complex number. So basically a complex number comes as this, we can denote the complex number as I, and I is equal to the square root of -1. And notice that it makes sense because remember that in the eventh root, the even root has the index 2 in this case. You cannot have a negative number if it's a real number, right? So if there's a negative number, it means it's going to be a complex number inside the even root, right? Complex number, not a real number. Okay? So judging from that, you know that I squared is going to be equal to squaring the radical of -1, which gives you simply -1. Okay? But remember, this only works when you're dealing with complex numbers, non-real numbers. Okay? So now let's see. If I give you something like this, negative 36 inside an even root, you know immediately that you can break this up. You can break this radical into two radicals and multiplying themselves, right? And you can say radical 36 times radical of -1. And how do we know that? Because we know that it's also equal to negative 30. Well, let's have. We know that it's negative 36 is the product of -1 and 36, right? So we knew that we can break this up into two radicals. Okay, that's the properties of radicals. We can multiply whatever the number inside. If you can find the factors of that number, you can separate these factors in separate radicals like that in a product. So as a result, we know from this that radical 36 is 6, and radical of -1 is still staying there. And remember that radical of -1 is a complex number I, so as a result it's 6i. Okay, so that's your final answer. Now let's try to use conjugates. So if I give you something like 7, well, let me erase that again. If I give you like 7 plus radical of -16, how are you going to put it in standard form involving complex numbers? How are you going to put it as I? Well, you're going to again break up the negative radical 16 into a product of two radicals. Okay, so you're going to have 7 plus 16 times -1, right? And then it's going to be 7 plus radical 16 times radical of -1. And then you're ready to work with the i's, and then 7 plus 4 times radical of -1, and that gives you 7 plus 4i, right? Because square root of -1 is I. And now finally, let's try to use the conjugates. So if I give you an expression like 31 plus 2i, the conjugate of that is going to be 31 minus 2i, right? So that's the conjugate. So now if we have something like this, 3 plus I divided by 3 minus I, how are you going to make sure that the denominator does not contain the i's? Well, you're going to use the conjugates, right? Because the conjugate of the denominator in this case, and why the denominator? Because you want to have a number in the denominator, no i's in there, right? You want to have real numbers only. So to make sure that happens, you have to multiply both the numerator and the denominator by the conjugate of the denominator. And the conjugate will be 3 plus I, right? So that's why we multiply both the numerator and the denominator by the conjugate. So now we use the FOIL method, so we're going to get 9 plus 3i plus 3i plus I squared, right? Using the FOIL method. And on the bottom, we're going to have 9. And notice that the middle terms go away. That's why we're using the conjugate to have only real numbers and no complex numbers. Oh, sorry, this looks like a G, doesn't it? Let me make sure it looks like a 9. Yeah, I write 9 like this, but it looks like a G. So let me write it clearer. So again, we're going to have 9. Okay, so 9 and the middle terms go away, so we're going to have minus I squared. So now remember what I squared is, right? Since I is radical of negative 1, I squared is simply negative 1. So as a result, we get 9. Oh, again. Oh, yeah, my 9s are really amazing. Okay, so 9 plus 6i and plus I squared, so we're simply talking about plus minus 1 because I squared is negative 1, so plus minus 1 is minus 1, right? And then that divided by 9 minus I squared. What's 9 minus I squared? 9 minus negative 1, right? So as a result, we simply get, what's 9 minus 1? We're going to combine the like terms. We're going to get 8 plus 6i over 9 plus 1 is 10. And of course, you can reduce it and have two terms with two fractions, two separate fractions. What's 8 over 10? Well, let's do it step by step. 8 over 10 plus 6 over 10i, right? And now you can reduce the fractions, and 8 over 10 is the same thing as 4 over 5, right? Because the greatest common factor is 2. So you divide by 2, both the numerator and denominator, you get 4 over 5. Plus, and using the greatest common factor of 6 and 10, which is 2 again, is going to be 3 over 5i. Okay? So, hope you enjoyed this video. I'll see you in my next one. Thank you.